Today we start working with differential equations, and a lot of this we already know what to do for the most part. But I'm really just going to start off with an example, and then we're going to move forward from there. Let's say that we are asked to find the general solution to the differential equation. Well, first off, differential equations, just so you know, are a whole nother branch of mathematics in the calculus world. We could spend a whole, semester on this, really. But for right now, we need to know enough to be able to handle what's on the AP exam. They're going to give you something like this. They're going to say dy dx equals 6x squared plus x minus 5. Something like that. All right? Well, if they say find the general solution, and I want to emphasize the word general, then the best way that I can explain this to you is to recall, remember when we did the derivative, let's say that I had f of x equals x squared, and f prime of x is 2x, right? Didn't we call that the general slope function? The general slope function that would tell me the slope of the tangent line anywhere, okay? It's going to be kind of the same idea, all right? We're going to get a general solution here. So how can I do this? Well, what I want to do first is I want to integrate both sides. I'm going to integrate dy dx, and I'm going to integrate 6x squared plus x minus 5. Now, if you remember, dy dx is just another expression for the derivative of something, right? So if I integrate a function, that is, whose derivative is dy dx, then I'm just going to get, the function is y. All right? That's easy enough. The right side is fairly easy. It's a fairly easy antiderivative. It's going to be 6x cubed over 3 plus x squared over 2 minus 5x. Here's the important thing. I told you this would become more important later, plus c, because this is an indefinite integral. And in differential equations, this c becomes pretty important, as we'll see later on. So if I simplify this, I have that y equals 2x cubed plus 1/2 x squared minus 5x plus c. This is the general solution to the differential equation. That's the general solution. The reason it's the general solution is because of this plus c. All right? Well, sometimes we will be given enough information to find out what c is. All right? They will say something like, let's kind of redo this, not really redo, but let's add something. Let's add something to this problem number 1. Let's say, for problem number 1 that we just did, let's say that I was given that f of 0 equals 2. If I was given that, this is called an initial condition. All right, if I'm given that initial condition, then now I can find what's called a particular solution to the differential equation, and I'm going to abbreviate with the DE. And it's really simple. I mean, this is really easy. Watch. If I have this initial condition, then all I have to do is take my general solution. Now, isn't y the same thing as f of x? Right? So let's rewrite my answer here. F of x equals two x cubed plus 1/2 x squared plus 5x plus c. All right, there was my general solution. Okay? Is that what I had? Did I make a mistake there? Oh, it was minus 5x. Thank you. All right. Now look what I'm told, though. I'm told that f of 0 equals 2. Doesn't that mean that if I plug in a 0 into the function, I get 2? So let's do that. Let's put this 0 in here, here, and here. And if I do that, watch carefully, if I put in that 0, I'm told that f of 0 equals 2. If I put in that 0, it should equal 2. And it's going to help me find out what c is. So watch, I'm going to have 2 equals 2 times 0 cubed plus 1/2 times 0 squared minus 5 times 0 plus c. And of course, all of those are zeros, aren't they? And so I just have that c equals 2. Guess what I have now? I have a particular solution because I know what c is. My particular solution means that I have found out what c is. My particular solution is f of x equals 2x cubed plus 1/2 x squared minus 5x plus 2, what I just found out. That's called a particular solution to the differential equation. The only way that I can find a particular solution, the only way, is if I am given an initial condition like this f of 0 equals 2. That's the only way that I can find a particular solution. Otherwise, it's going to be a general solution with a plus c. Okay? So, tonight, let me do another example here of where maybe you're just asked to find the general solution. All right? Let's say that we are asked to find the general solution. Find the gen solution of dy dx equals secant squared plus 2x plus 5. Okay? Well, we're just going to, like I said before, integrate both sides. All right? I'm going to integrate the left side, which is always just going to give me y. Or, you know, I could also put in f of x if I wanted to. And then I'm going to integrate the right side. I'm going to integrate secant squared plus 2x plus 5, and it's technically dx. So this y is going to equal, this one's a pretty easy one, but let's just, you know, just humor me here for a second. The integral of secant squared is tangent of x plus 2x squared over 2 plus 5x plus c. And so my general solution, this problem's easy, is y equals the tangent of x plus x squared plus 5x plus c. Okay, that is a general solution to a differential equation. Now, what if, let's do another initial value problem. Let's say that we are asked to find that's supposed to be a find, particular solution to the differential equation, I'm going to abbreviate with the dE, dy dx equals e to the x minus 6x squared, whose graph passes through the point 1, 0. Now guess what? That is an initial condition, right? I am given an initial condition right here. And it's written a little differently than the one I just gave you, but doesn't it mean the same thing? Couldn't I write this as f of 1 equals 0? Couldn't I write it that way? If you plug in a 1, you get a 0, right? So now, let's solve the differential equation. Well, I have the integral of dy dx equals the integral of e to the x minus 6x squared dx. So the integral of the left side is just going to be y, or I'm going to put f of x, all right, just because I think it helps us with our initial condition, equals, well, the integral, the antiderivative of e to the x, since the x is just an x, not a 2x, is just e to the x, minus 6x cubed over 3 plus c. So that means it's going to be f of x equals e to the x minus 2x cubed plus c. But look, I have an initial condition right here. I know that f of 1 equals 0. So that means if I put a 1 in for x, it should equal 0. So let's do that. E to the 1 minus 2 times 1 cubed plus c. So let's see here. This is going to be 0 equals e minus 2 plus c. And we want to solve that for c, right? So 0 equals e minus 2 plus c. I'll subtract e, and I'll add 2. So it looks like c equals 2 minus e. So my particular solution now, okay, we're not done, that's just what c is. My particular solution, I need to take this and put my c in. So my particular solution is f of x equals e to the x minus 2x cubed plus my c plus 2 minus e. And there is my particular solution. And we are going to stop there for today.